Good morning. I always leave myself short of like one thing I need to do. So I think I got it now. I think I got it. Welcome to episode 2, where I'm going to be going over material in this book and other material related to learning Go. Last week we covered a fair amount of ground, got several IDEs installed and running with code. Goland is one of them. Visual Studio was the other. So that was all most excellent. Covered a lot of material also around variable types, how to declare variable types, and also declared our first function, including how to pull a dependency, go random data, this example right here in front of us. Basically, it pulls a dependency, which is called go-random data, and then the example, as this shows, generates a bunch of random data about first name, last name, country, locale. I think it did IP and some other things. Yeah, IPs, postal code, paragraph, all sorts of good stuff. Yep, there it is. IPv4, IPv6 address, user agent string. So great set of testing data. And here's some of our other functions that we wrote. And we also worked with the terminals here, like this one in Visual Studio Code, and over here, this one, I think. We got a local Git repo started. So I did git init, and then committed this code that we have to this repository. One of the first things I'm going to do is actually, let's update that real quick. Update. There's our little 9cat. We did get the 9cat plugin, which seemed like a pretty phenomenal win for cool things to see while we're waiting for IDEs to do things every day. Let's see here. So I wanted to kind of recover a few things from yesterday. The first thing I wanted to talk about was, what was it? I took some notes on this, trying to remember what the heck I was going to go over. Oh yeah, Go format. Go format is a thing that basically formats the code. Go is very specific about how and where it wants things in the code, which is pretty awesome, honestly. I personally can tell you about a million stories where a JavaScript project is in the works. We're about to start a JavaScript project, the team pulls together, and the first thing the team does is debate and try to figure out what coding styles, what coding formats, what coding structures, and all sorts of stuff are going to be used. And that discussion goes on for sometimes the entire length of the project, and the argument and the cycles spent dealing with that are often, how should I put it, excessive, and sometimes a waste of time. Let's just be blunt. With Go, there is a convention around how Go code is written. Go format is part of the tool chain that will help you format your code the way the convention is expected. So let's let's look at a few little examples of that. So here I am in Goland, and let's just close the gitignore file. We'll open up the main file. There, here's some stuff. So let's do something as simple as we mess up the spacing. Okay, why even mess up the spacing? Well, I'll let IDE let me do it whimsically. Let's do the format, print, line, testing. Okay. So yeah, it did let me do that. Now that's an example where see, it's just out of line with the rest of the elements. But if we type go format, I believe. Yep, see it put it when I hit go format, it literally lined that up correctly. So now if we do nested things, let's say we go for a for loop. Like this one, let's say just put all that back where it should be. See, that's a pretty hard to read situation. You have everything without any spaces, and sort of. Let's see how much it'll do. Actually, so do that, and then let's put this one up here and just make it a total mess, right? So you could write Go code, and that would work, but it doesn't follow convention about how or where Go expects the code to actually be. So let's do a format. I'm gonna do it one more time just for good measure. And there you go. See the file updated, and it put everything where it needed to be. So Go format is an important part of the Go toolchain. It is built into the IDEs. Now, Visual Studio Code also has Go format plugins. Like, let's see if we can actually go and look at some of the plugins. Go format. Why is it not? Let me put there we go. Couldn't put a space in it for a second. So a lot of these things go to spec. Switch between the code and the spec file. SK translation format A. Well, some of these are a little weird, but see, Go, all sorts of plugins for Go around making sure it fits various elements. But I'm betting that this one, this Go plugin, which we already have installed, yeah, it says has auto completion, has signature help for functions, quick info symbols, does code navigation, and I bet it has Go format. Yep, there it is right here. So format code on file as well as format manually using Go returns, Go imports, Go format. So that's pretty slick and also good to have in the tooling. Most of these plugins will have some form of linter also. So if you try to do something that just doesn't mesh with how to declare something by convention, or you've left out comments on important things, or you used casing that isn't the convention in Go, then the linter will catch that for you and fix it, or at least tell you how to fix it. So that's some pretty awesome capabilities that are pretty much built into the default Go chain. It's one of the beautiful things about Go and the Go tool chain. All right, let's see here. More book stuff. Some other things to note. Go is, the syntax is generally C, C++ based, but you won't see semicolons barely anywhere, which honestly I'm fine with. I don't know why we need semicolons anyway. It's a bunch of cruft. In JavaScript, if you're learning JavaScript, you'll notice that semicolons are pretty much optional in most places. You can put them there and say this is the end of the line, or you can just not put them there and go to the next line and start writing code. As long as your code uses good formatting and clear, easy to read formatting, it doesn't cause confusion. But there are situations in JavaScript where you do a lot of things multi-line or multiple things on a line, and then you need to use semicolon within that to designate where each command ends in that particular control structure, like a for loop or something like that. So some cases it's needed, but in Go it's not particularly needed, especially as long as we use the convention. All right, one of the other things was to do. Okay, we did the command line arguments. We looked at that. We did the breakout on os.args, which is it's an array or slice more specifically. We'll talk about slices in a little bit. Slices are basically an array in Go where you can actually add elements to it and take elements out of that particular slice array. Whereas an array is assigned as a static set. You have to make it a slice basically to add or remove stuff. Let's see here. There's another cool thing I wanted to dive into. Oh, here is the example. I've not given myself any space on this, and now I've gotten my Velcro shit stuck to everything. 80's called Once Your Velcro Back. All right. So this next example we're going to do, this one's pretty slick. Well, at least I like it. I like to do little string manipulations within my code base as whenever the chance comes up or the need, which is pretty frequently when you're writing code. So anyway, this is a little application to find duplicate lines. And it's one of the examples that is in the book. As per episode 1, I mentioned many times, this is the book that I'm working through. The bulk of the material I talk about will be in here, like the core reference material you want to know about is in this book by Alan A.A. Donovan and Brian W. Kernighan. So, really good book. Go get this book if you want to learn Go and want to follow along as I go through all the material in these sessions. In addition to the other material that I will be adding, such as all this IDE information and all this stuff, which it's always cool to learn about the tool chain, but there's always the assumption that you kind of know about all the other bits. I'm not making any assumptions. I'm adding all the bits as needed. Started from a completely blank Ubuntu virtual machine image, which is what we're looking at right now. And from there, I am working toward whatever it is we're doing each day. And I'm going to save spaces or save states. I will also be putting some of this code eventually at some point into GitHub, and the repos will be available. This first beginning code, though, I'm not putting it in GitHub just because it's kind of, well, honestly, it's kind of throwaway code. But let's see here. Let's do a new. Actually, whoops. Yeah, we're going to do a new project today. Let's do Go path. We're going to leave it set to that. And the modules, we are using 1.11.4. Dep is enabled. And I'm going to go ahead and click Create. And let's say, put it in this window. So in Goland, it options for, do you want to open up an entirely new IDE for this project that you're starting? Or if you're opening something, it'll ask if you want to open up a completely new window. So you can have multiple IDEs open at one time with Goland. This is something that doesn't particularly work with like Visual Studio Code. It's a little different about that. You're always in the active application within the multi-document window interface. Oh, it named it for me? That's cute. Nothing in the vendor. Let's go in, new, Go file, and we're just going to call it main. Instead of empty file, we're going to say simple application. And it gives us a little bit of skeleton. Just, of course, the package main and the func main. So in func main, and one of the reasons I also wanted to build this application is it helps us go back over some of the stuff we previously learned, just kind of as a refresher. I'm going to say counts, and then it's equal to make map string int. So what is that doing, you may ask? Well, simply, it is assigning or creating a variable called counts, and then assigning it the value of what make does. Make is a way similar to new that will allow you to instantiate a variable and its associative values and make that object, right? Or make that element. Also, just a shout out, hello to people joining right now. Hello S&B. Yeah, I don't. So the mouse pointer, just to make a mention of that, I don't know what's going on with that. That's something that has popped up in the last, I don't know, a couple hours. I redid some stuff on my virtual machines. I also have added guest additions to my VirtualBox virtual machine. And now, even though everybody in the stream gets to see it at a reasonably sized, I think, like 10 by 9 size with good resolution, because I think I have it set at like 1440 by something. And actually, let's look at that. Talk about it just for a minute. But yeah, if I go to devices and then look at this, oh, 1680 by 1050, 16 by 10 resolution. So that's what everybody gets it at within the overall 1920 by 1080 or 1080p stream that I'm doing. But I am stuck with this sucker being one little itty bitty square on my HD screen because it's not resizing it according to the fact that that I have this on a machine that has HD screen. So Windows seems to be completely clueless about informing VirtualBox about that. But I digress. That doesn't matter to you. That's my problem. So I'm going to cope with that problem and squint. Anyway, so we have counts now, which is being made into a map of string ints. I guess is the way you can say that. And then we're going to add an input variable, and we're going to set it to some buffer IO. Buff IO is the library for that. New scanner, and then we're going to use an OS element for standard in, and you'll see it adds the dependencies up there in the import for buff IO and OS. So I'm using standard input, that's std in the library, and we're using buffer IO to create a new scanner. I'm going to do a little loop, say input, scan. That's basically taking input from your keyboard. And so for each thing entered, basically scan and loop through that counts, and we'll get some values. Input text. There we go. And then we're going to iterate from that with plus plus. So that's going to give us a count. And for line is equal to range. So that's going to give us a for loop to step through each of the line elements of counts. Then if n is greater than 1, brace format print f. Print f is for format, and then we use one of our formatters, %b, and then let's see, %s, and then a new line. I think I did that right. Comma, n, and then line. So let's, here's a little build here. Go in, go build. I want to do the package, not just the file. Let's just run the whole thing. That looks good. And I'm going to run debug on that. There's a 9cat running down there, and boom. Okay, it's waiting for input. So this is a oh, yeah, I have to do it this way. All right, so we ran that, but we didn't have any input in it. But we can go into program arguments and let's add some stuff. This Let's see what that does. Then we run that sucker. All right, so with this, let's talk about this for a second. So the map is supposedly holding a set of key value pairs and has so it's going to hold the key value pairs of the buffered input coming in as we step through, right? Yeah, so the built-in function we use, make, creates a new empty map, and then each time a dupe reads a line of input, the line is used as a key into the map, and the corresponding value is incremented. The statement counts bracket input.text bracket plus plus is actually equivalent to doing 2 lines. We could do line is equal to input.text and then counts line array equals counts line plus 1. Let's see here. So my question is how do I do? That doesn't seem to handle my input. Oops. Oh, it doesn't exit the for loop because it just keeps giving you the count like as you type or as you take input. But that's the thing. This situation that might not work because I thought I would get to add the input here. Oh, that's not how I want that. This is a line of text, and then this is another line of text, and this. See if that works. We'll do this, we'll do that, and then run it. Let's step in and we'll debug. Okay, we got line in. Oh, this is quite perplexing. So it's got that, and then, yeah, I thought that I could just type and it would take it in, which is why the for loop is discontinuous, because it keeps looking, basically anything you type, I can't type, it's not letting me type. Okay, let's not use the debugger here. Let's do, we're going to close that, we'll open up the terminal, we'll do it manually. So go build, and then we're going to do awesome project. This is a line of text of a line of text. Yeah, you got a good point. That's not going to work. Let's refactor this by removing that. Not entirely. Let's do kill that. There we go. Maybe that's not that bad. So when you count. Let's see if we can do this by file instead. We'll go ahead and create a file. Redundant. We'll just call it text. There we go. we'll say this text. This is another line of text, and then this is a line of text. All right, so we definitely want to do count stuff. And files, look through, let's do os.args. We'll pass in via the command line. And let's say if make the files is equal to 0. We'll just I'm building this example by the book. I'm kind of curious what the good one here is. Okay, so we're going to do count lines and os.standard input. Okay, and then counts. And let's go and create a func. It's going to count the lines. This. And here we're going to have pointer to file and counts. Yeah. Similar to variable declared up above, just like so. And there we go. So we're going to take input, or create an input variable for buffer.io, do a new scanner like we were doing before, and pass it reader, which we're getting passed in via a function parameter. Then we're going to loop through that input scan, and we're going to get counts of it. So counts, input text. There we go. And then iterate on that, or increment on that, I mean. So there we have that part, and then we want to say else, do this, and here we're going to say for, remember that underscore is, a parameter will be returned from a function, but we don't want to act on it, so just take it back and let it be, but then take another value, arg, from this function of range files, which will give us what we're going to iterate over in the for loop. So say f error then, and then attempt to open file. So arg. So that's basically the os.args array 1 will be give me the first value that's passed in, and that's what we should be opening up as our file. And then here I say if error, not if error not equals nil, then act. And here just say format. I'm going to printf. Say the error happened. Oh no, it's and this, we'll pass it in, OS standard error, like so. Okay. And then we're going to say continue, which will act as a continuance instead of returning an error or returning a value. Continue on, it just says continue. And then we're going to again call count lines function. F counts. And then f dot close to close the file. Why is that unhandled error? So f dot close most likely has like a value and then an error, like this, right? assignment. Oh, just it passes an error. So if there's an error on closing the file, I'll pass it like that, and then I can handle it. With another, say, if error is not equal nil, right? But with a lot of these functions too, you can just skip that whole thing. You just call the function. Matter of fact, up here, we could just skip this and leave out the assignment if we didn't need F to work on. We need F to be able to count lines, etc. So with that done, let's move. Let's see. To the if else if, and then yeah, for line equals in line comma in blue range counts. And we'll do if n is greater than 1. Format print f. And now that crazy. It always looks a little crazy with the string parsing and concatenation. All these formatters. And S, and then a new line. I want. We'll do in, and then line. I believe we have that right. If we do this, we're done at parentheses. Oh yeah, that's another thing. Keep the code noise down to a minimum. We don't actually need that outer parentheses. We just need the inner parentheses because length has to have a parameter pass, so those parentheses are needed. But the outer ones aren't on an if, or as you'll notice on a for. Sometimes in a lot of languages you'll see parentheses around things like this, and that just simply is not needed in Go. So let's we have our file, which we named what text.txt. So let's actually put that in our build executor as a program argument. Text.txt. I don't know how it's going to handle that dot. I always forget exactly what happens to see a lot of that. So we'll build it. Say 2. This is a line of text. So those two are repeated, correct? That looks like what we expected in this scenario. Yes. So then let's say another thing. Blah, blah, and then oh, that'll be interesting to see if it does it by case. We'll do blah again. Let's see what happens. There we go. So yeah, it didn't see these two as the same because it is case sensitive, which is important to note. So we have 2 lines of this is a line of text, and we have 2 lines of blah, period. So that worked a little bit better doing it from the file like that. Pretty slick little piece of code. Shows you how to do a lot of things that you can get pretty far with just with that functionality right there. Parsing in a file, looking at the text, and finding duplicates. Let's see. Let's go to the terminal. Let's actually go through the process of getting this committed to Git. So git init. That's going to be our first Git repo that we'll actually put in GitHub. But one of the other things I wanted to show you in Goland, which I love this feature, when you use the interface to actually commit code, there is an option. As I was talking about before, there's Go format, which is part of the toolchain. Here, Goland goes even one step further and offers an update of copyright, which is not Go code, but in the license file, things like that. It looks for copyright, make sure the dates are updated. But you can optimize imports, rearrange code per coding standards that you impose on your Go code. Also, in addition to reformatting the code, which is basically Go, kind of like Go format, but again, going beyond and adding your particular characteristics that you set in Goland that you want for your code base. And of course, down here, as you can see, it's automatically checked Go format. Let's see here. I'm going to, oh yeah, I need to add some things to make sure we don't have a bunch of junk in our repo. So as always, add a gitignore file. And I'm going to say no because I'm going to add this manually in just a second. And let's check out the feature of add unversioned files. So that basically tries to add everything because there's no state or no versioning existing already in the repo. But what we don't want is the ones that we actually are trying to use here, which is main.go and text are part of the project. At least in this case, I'm going to have the text file be part of the project. And these dependency files, I want to commit when we get to that point. Let's see, I'm going to cancel on it this time. So I also don't want to ignore the actual gitignore file. I do want to ignore the .ida directory. Some people may want to check in certain things or elements of the settings for Goland, but in this case, I don't want to. I don't want to impose on anybody my Goland features. The awesome project is the executable. I don't really want to do that because whenever you pull it down on your machine, whether it's Windows, Mac OS, or Linux, you can do your own build and get your own executable for your platform. You don't need my executable. It's not something that I'm distributing in this case. So I just want to keep it out of the repo. And then the vendor directory, I also want to keep that out of the repo because, again, whenever you pull it down from a repo, you'll need to build it pertinent to your machine. So you'll want to do a Go Dep ensure, which, again, we talked about Go Dep in the previous session. We'll cover it again a little bit more in how we use it, etc., as we move forward through this material. But basically, vendor is where all of the dependencies will be put into that folder for the project. And you want to build those dependencies per the system you actually bring that code down on. Again, specific to whatever the OS is, etc. So, pretty easy thing. It's just one extra little step, and we'll add that in the README. So let's go out and file. Let's add a readme.md file. I'll go ahead and say yes here. So what Goland does is you'll see it go green. The text of the file goes green, which means it's added it to the commit for the next commit that goes in. The red files are not included in the commit yet. So I'm going to actually go ahead and use a shortcut key called Control-A. I'll right-click and show you what this is. I believe you have Git, and then you can add it to the commit file here with Control-Alt-A. Actually, I was about to use the wrong shortcut key, so it's a good thing I did it that way. And then, of course, you can select multiple ones and then do Control-Alt-A. And now we have all of those already in our commit now for whenever we do our next commit. So, like if I hit shortcut key to bring up the commit window, ta-da, we'll see all of our files. And in green, you'll see new material. And since this is the first commit, everything's going to be green, right? Now, if you already have code in there, you'll see this later as we do commits, it's going to be green and red. Red will be stuff that's deleted, green will be stuff that's new, and then white will be stuff that's just simply unchanged. I'm going to also check cleanup, update copyright, optimize imports, rearrange code, and reformat code, because Goland is that trustworthy. If you have a good project and it's formatted well, Goland will do you right. It will help you out a lot. Viso should give me sponsorship money. I drink a ton of that stuff. I love it. Some people hate it, some people love it. So at this point, since I also don't have a remote repo, I can't really commit and push, but I can do a commit locally. So I'm going to go ahead and do the commit. Oh, yeah, of course. Good standard. This, I'm just going to say first commit duplicate line finder. And then hit commit. And there it says some files contain problems, no errors, and one warning found. Would you like to review them? Let's review that warning. What does it say? Warning, unhandled error. Now, you probably remember exactly what that is. Yep, f.close. So if I was going to follow convention and good practice, I would do equal to that, and then come down here and add a track for it. nil. Tell me what happened. Print line. Holy moly. The file didn't close correctly. How could that even be possible? I don't know. That would be a weird issue to see, considering it's a pretty clean close. No hanging memory, nothing like that for this one. But that removes that for us. Oh, let's do her. Oh. I complain about that too. Whoa, it's not that warning. Sometimes autocomplete will kick you when you're trying to do something. Alright, so that looks good. Let's see what we get now. We should get a commit that is super clean. If you hit Control K, you'll notice since this commit didn't go in, the commit message is still there, the files are still checked, etc. So let's hit commit now, and boom, it just goes. When there's no warnings, no errors, no nothing, it's just gonna put the commit in. Because that's the easy step in Git locally, is you've committed it to your local repo. Now let's actually go through and get this up on GitHub. Is that cursor still giant? It's so crazy. It's just, it's not so huge. Like github.com. Cool. And here I'm gonna just select new, and let's call this. So what should we call this? Anybody got an opinion? Any opinions on the file name? Or repo name? I noticed Aussie Robabi is auto-hosting me, so I just added him. If you want me to auto-host you, just throw me in your auto-host file. When I see you hosting me, I'll definitely add you back. I think, I know what I should name it. I should name it per whatever I'm naming these videos, this video series. That would be smart, right? Since you're calling this Learning Go. So let's do it pertinent to that. We'll say Learning Go episode. Actually, let's just do Learning Go episode 2. Duplicate time finder. Now here, one of the things I love to use is in the Git file here, you can just pick Go, and they have a gitignore file for you. Super awesome. But in this case, I'm not initializing the repo. Since we've already got it locally, I want to use that to push up as the latest bits. So in here, GitHub is always lovely. It gives you that path and then tells you the steps you need to go through here. How to add the remote repository location. Sweet. PJ, welcome to Twitch land. Let's see here. So now, all I gotta do is go in here, and I'm gonna do this via the terminal. There's a way also to go in and do it through VCS, Git, blah, 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 push thing. We'll look at some of that later as we play around with the IDE. But I like to start from the command line because it kind of gives you a basis for the steps that are actually going on and the things that are sometimes hidden in the IDE, which can lead you to be confused when it skips steps that often you might actually want to take. So in this case, I'm going to say git remote, and I'm going to view what remotes I have, which should be nothing because it's just a local so far. So I want to add a remote, git remote add, and then I'm going to call this origin. It's important that when you create origin, that it is the default remote repository that you're using, because generally speaking, Git, the default repository, remote repository that you are connected to in Git will be named origin. So there's some convention around that. Since this is going to be our main one, that's what I'm going to go with. So, and then copied from, again, just to look, right here is your actual URL where the remote repository is located. So I just paste that in. I'm going to add that. So now when I look at my remotes, boom. Notice I have a fetch and a push that is designated whenever you add a remote. So you can get specific about this, but we're just going to go straight with the simple stuff right now. So I got that remote added. So now I can actually push my code to it. One of the things that I want to do, which is mentioned here and kind of important, you'll notice the -u. Okay, so what that does is it says push my code up to the remote repository, but also map my local branch, which right now is just master. We don't have any extra branches, so we're only dealing with the one branch. And we already have our commit, so we've already done the steps where you see git init, git add, readme.md, and then git commit -m meaning message, and then the message first commit there. We already did that in Goland. And then we just added the remote, and now we're going to do the push, and the -u is going to map our local master to the remote master. So whenever we do things here, it's going to check against that for its state and time basis of where we're at within our commit log and everything. So let's bounce back over here and get it done. Git push -u origin master. And then you have to have your SSH key already generated. If you don't have an SSH key created, I have a little blurb about it on my blog. If you go to composite code, and then you just search for ssh-keygen, have the basic immediate syntax under git commands and info right here. Oh, that's the other git branch thing, but right here. So ssh-keygen -t rsa-c, and then you pass in your email address, and that will generate a key for you. I've already put it up on GitHub also. So when you do it the first time, it'll ask you if you want to continue to connect and trust this connection. And I do, because I know it's mine. And could not read from, oh, that's great. Oh, maybe I don't have a key set. So let's do that. We'll just go through the process fully. Already closed it. Well, whatever. Okay, so keygen. Oh, yep, already forgot the syntax. It's that fast. Memory. Code. And then keygen. This one. Oh, ssh-keygen. So ssh-keygen -t rsa-c, and the email address Adrian at. I just say my name that way. Adrian at thrashingcode.com. There we go. And then all the secrets, you didn't see none of those. Forcing me to put in my password. But what I would do now, oops, let's see here. I'm going to check one thing about Goland. We're going to learn two things at one time here. First, we're going to find out if Goland is actually added to the command line. If it's not, it won't actually open my file right now. Let's see, ssh ID public. So we want our public key, and we're going to put it up on GitHub. Now, this probably ain't going to work. Yeah, so you see, Goland is not actually set up at the command line. So what I do is, the easiest way to do this, that is, go to Tools in Goland and click on Create Command Line Launcher. And just say OK. Ask for permission. Yes, do that to my system. And then now, whenever you type Goland, whether in this terminal, in Goland itself, or another terminal, like this one, like I can say Goland dot, and then it's going to open Goland and open the current directory that the executable is being called against. So in this case, I just opened up my key, and I'm going to go out to GitHub. You go click on your icon, go to settings, then look for SSH and GPG keys. And here, I guess I named my, I know what I did. So there's the key, virtual machine, go learning. Oh, bear with me, I gotta look up my password. Oh, I think I actually remember what it is from memory. Of course I don't remember what it is. Bear with me. Just a minute more here. Oh, that's one there. Ah. There we go. Okay, so there's our SSH key. It's in there now. So I can go back and use the SSH get connection to actually push this up there. So we're going to say git push -u to map it origin master. Go through. And there we go. Notice there it says branch master set up to track remote branch master from origin. That's what that -u does. So now whenever we do git push, git pull, it's actually acting against master. Yeah, I actually have 2FA set up, which is kind of weird because shouldn't it have sent me a key or told me to use my factor thingy or whatever? Oh, stretch. I don't know. I kind of get confused as to what it's actually determining it needs to do the two-factor on and which ones it just lets me put in my password for. All right, so close that. We have all of our stuff up there now. But let's do some other system stuff before we get back into any Go. Because honestly, one of the things that I find all the time when learning a language, people learn a language and they don't know what they're supposed to do with it. Peripheral to that. So let's just do something super simple. Let's set up a Travis.org. This site has builds. Oh, that is not what I was looking for. Travis build. Yeah, Travis CI. Oh, TravisCI.org. Travis, your website is in the way. Go back here, and we'll look at our actual repo here. It's sample one. Go here, and me, and repos. I don't know, I still feel like the navigation for GitHub repos via the interface is a little funky sometimes. Well, this is super trippy. Did I spell it wrong? readme.md, and it wants to add one. Let's see what it does. Test. Sure. Duplicate line finder. Commit. Yeah, okay. GitHub. You need to write a duplicate application finder, file finder thingy to make sure you don't try to recommit something over the README. That just seems dumb. We're gonna get rid of that message. Oh, I know what. Let's delete our README here. There's the delete file. Delete that. Okay. Commit real quick. Yep. And here we're gonna actually say commit and push. 9cat runs, and please push up to the repo. Now, what'll be funny is if I update this, Okay, so I was gonna say we take away the README and watch this disappear because it has like some weird reverse selection. So we're gonna go in here. We're also gonna go in here. I'm gonna sign in because I already have an account on travis.ci, and we're gonna look at what it takes to get a Go build running here. So you can see that I already have a bunch of stuff building. Some of the other projects that I actually am building on Twitch on a regular basis are already here. We're just going to follow the most minimal steps necessary for this. So if you click on your user, you'll see all of this pop up, which is all of your repos and all of your orgs. You can see I have kind of a few. It's paged out. So the easiest way, though, is come in here and say, it's learning. And there is the repo. I'm going to turn it on and then click on settings. From here, you'll see various little options and stuff. And one of the options, which I believe is in here, it says build push branches. So if you make a branch off of master, like say my test branch, I'm building duplicate file checking and duplicate looking for periods or some crazy thing, whatever it is. You could say for any branch in the test you want it to also build, so then you would have multiple builds going off of one there. You can add environment variables, which are specific to the build, cron jobs, and all sorts of stuff. And you can do it based on the branch. Of course, right now it's just the main one there. And then this says no builds, because we haven't pushed to it yet, no branches. And then, even though I find this wildly unintuitive, the way you can add a badge, just like this build unknown, to your repo, you go here to this screen, and you click on it, and ta-da! It lets you pick what you want to do. So I'm going to have a status image for master branch. I want a markdown text, and you'll see it changes the text to markdown. Like you can have HTML too, I think, or something. Well, image URL is basically your HTML. You have to add your own thing. RDoc changes to that, and ASCII doc, pod, CC tray, all that jazz, right? So I just want markdown. Got it copied, and I'll go back over here, add that here, and then just say adding Travis CI build badge. Okay. Badge. Commit new file, and there we go. Now somewhere in here, I often forget, you can set build if there's a Travis CI file or if there's not. Right now, here's our repo. Should look like this with build unknown still, because it's basically now set up a hook where when you commit to it, it'll build on new commits. But I want to go and see where in the world is Comic Sans. I'll use Comic Sans. A new dashboard. Okay, that's cool. Repositories. I don't know where it's at, but let's take a look. So this CI Go build. Building a Go project, Travis CI, and that's what we want to do. So we just want to see what a basic file looks like. You can see all the other languages that you can build. Here's Go. Here's ours. So I just want to add this much into a .travis.yml file. I'm going to go here, and I'm going to actually do it via this interface. Create new file for language.travis.yml. And then I want our version 11. Let's see, what is our version we're using again? Let's check. Go version. It is Go version. Just one dash. No? Go version. There we go. Okay. So 1.11.4. So I just want to do 4. I'm going to knock out these other versions. I don't want builds in that. And I want master branch 1.11.4. So basically, it's going to be a version specific and a branch specific one. And then this is adding
grab this YAML build file. And it looks like I spelled it right, so everything looks good. Let's commit that new file. So that should get us a build in a minute. Do I have a favorite programming language? The ones I write. No, I write code in a lot of different languages. I write JavaScript. I like JavaScript. Some people hate it. I'm cool with it. There's a lot of cool capabilities it has, but I also dislike it for things. I like Go for other things. I tend to like programming languages pertinent to what it is that I'm doing. If I'm writing system stuff, like parsing files, managing servers, moving images, doing stuff like that, scheduling things, etc., and I want a binary that I can build and put out onto a server, Go is the language for that for me. I'm also finding that it's pretty powerful to do web development, like web services and stuff like that. Creates a built executable that can be run on a machine, and that machine can then run that service, be a microservice or whatever it is that you have. It generally builds faster, and it builds natively, definitely builds natively to you know, the system that you're putting it on, right? So you got this binary that you have that executes native to the system for your microservice or whatever that Go has. It's freaking awesome. Compare that to Node.js, which is never a built binary. It's always just executing code. There's certain binaries of its dependencies, but it's kind of getting into a complicated answer for that. So Node is great if you know JavaScript and you have JavaScripters that need to write stuff ASAP and get it done. Node.js is great. Then there's stuff like Java and C#, super built out, elaborate frameworks and libraries. But again, those things don't build natively. So they don't have the power of Go. So I love Go for system level stuff, services and system level stuff running on a machine. I still love C# for, let's say you're building a game. Great example, right? Use Unity and C#. Awesome package right there. Awesome framework, awesome package, gives you a lot of compatibility. Even possible to write it so that it will run in Linux, Mac OS, or Windows, which is beautiful. I love being able to write C# code and have it run on all the platforms that I use, because I use all the platforms. My favorite game right now, Transport Fever, and City Skyline, that's another favorite game. Both Unity games, runs on my Linux platform thanks to SteamOS, but it's written in a way that it can do that, right? But yeah, super rad stuff. One of these days I want to do a stream and hack some of the plugins for some of those games and just look at how it's being pulled into Unity, like the different workshop elements or whatever for like stations or trains or airplanes or whatever. Really cool stuff. So that's kind of my take on languages. It's dependent on the job, and I don't have any concern or frustration with learning additional languages. I know some people get perturbed. They're like, oh, I've really mastered this one language, and that's what I want to write everything in. But it just doesn't work out sometimes. Let's say I'm writing a really hardcore distributed system around file management or database management or something like that. I'd probably use Erlang, you know, or even oh shoot, I'm forgetting the offshoot, the kind of like write this code and it generates into Erlang. Completely spacing on it. Somebody might think of the term. You might know what it is, Bobby. But anyway, it gives you like a Ruby syntax to write to Erlang. So there's a lot of options to be able to get at. Oh, I see my build failed. Woohoo! It's always a failure at some point. But yeah, so there's always a way to get into writing something a little bit more with your syntax, usually your syntax preferences with whatever language you're using. So I like that. Also, there's functional languages, which are super badass if you want to, like F# is amazing for parsing data. Like you get a lot of text files to deal with. So let's see, we got both. You'll notice the Go master attempted to build and the 1.11.4 attempted to build. always weird. This one always seems to take forever, and then the specific one takes a few seconds. And you also notice that it takes quite a while on the server. Locally, of course, it builds in what, a second, 2 seconds, something like that. Go always builds fast. But let's see here. To figure out what our problem is, let's take a look at that real quick. Oh, I've already logged out of the machine. So branch, let's job log. What is our dilemma here? Oh, the Go test. Yeah, so we don't have any tests written. So of course it is going to fail. Printf format has a wrong type OS file. No, that builds. I don't know what your printf fuss is about, Travis. So anyway, we have a build now, and that's great. But we're going to come back to that because I don't want to sit here and focus on build debugging all day long. Plus, I'll probably just stumble upon what I just did in a second. Is it? Yeah, Elixir. That's exactly what it is. I knew somebody would think of it. All right, so we're gonna nip the build for right now. Clear it on that, and then let's get back to some Go bits. Look at that. This is what we need. All right. So this is our one file. And then what did I want to look at? Oh, yes. Just recover some type declaration stuff. I wanted to take a look at, let's see, we're going to make a new project for this one. Or should we? Actually, let's use Git in a really weird way, but an effective way to know how to use it. So I'm going to actually do a branch, right? And I'm going to call it Git branch. So what I did there was Git branch. That just shows you which branches currently exist. I'm going to do Git branch. Let's do temp app. We'll call it temp app for temperature app. And then I'm going to check out and by proxy move into the temp app branch like this. So it says switch to branch. If it gets status, also you can see it states there on branch temp app. Okay, so clear that out. And I'm going to nuke all this code. Boom, just like that. And I'm going to nuke this binary and delete it anyway. Do not check for usages. And I'm going to get rid of the text file because we're not going to use this text file. There we go. So main.go. And okay, making a type declaration. So type declarations are usually declared at the package level, where the name of the type is visible throughout the whole package. In this case, main.go is where we're going to declare it. Also, convention base in Go, types are declared with uppercase. So we'll do type. Actually, let's add package first. Package main. And then we'll do type. We'll have one for Celsius. We'll make that float 64. And then we'll have one for type Fahrenheit. And then we'll be a float 64 also. Now let's declare constant. And we'll things. We're going to declare a constant now. Constants. So we'll say absolute 0 Celsius. And it is of type Celsius. Notice we have it there now. It's a T. And we'll make it negative 273.15. And we'll do freezing Celsius. And again, that's Celsius height. 0. And then we'll have boiling in Celsius. And that will be 100. You'll notice when I use a type, oops, I didn't declare this right. There we go. So Celsius, once used in Goland, makes the type actually turn orange, so you know that that type is actually used somewhere post it being declared, right? So now let's take a look at. I'll just jab myself in the finger. Let's declare some functs to get our Fahrenheit measurements. So Celsius to Fahrenheit. We have to say it that we measure it, spell it right. Otherwise spell it wrong. So we're going to pass in the Celsius temperature, and then we're going to return a type of Fahrenheit, and then this is going to be our function body. So we're going to say return Fahrenheit Celsius times 9 divided by 5 plus 32, because, you know, let's use things that require really weird functions all the time, right? And then func Fahrenheit to Celsius. F Fahrenheit is what we pass in. We'll get back is Celsius. And then the function body. This is going to be return Celsius. Oh, geez, it's F minus 32 times 5 divided by 9. Is that right? Did we get it in there right? Yeah. Doing this always reminds me of how much our temperature stuff just is ridiculous. We really should just use Celsius. We should use metric. Metric all over the place. All right. Excuse me. Now, we don't have a main, right? We need a main so that it does anything. There's our main. Now we can say print line. Temperatures are hard to figure off the top of one's mind. Alright, so we can just build that and it's going to spit out. Bloop. There we go. Okay, but let's do some stuff and, you know, figure out what the heck. So we have the constants for Celsius, right, which is great. We can say something like print, let's do printf. And then we'll say, so let's get the result on the line above, just for readability. So let's say, boiling Fahrenheit. Boiling Fahrenheit equals, so we'll need to do the calculation of Fahrenheit, Celsius to Fahrenheit. There we go, and then we'll pass in constant of, let's do boiling Celsius. There we go. Okay, so we have the constant, we have the calculation. Oh, yeah, I don't know my font. If I can make my font bigger in here, because Goland is actually pretty cursed. Let's, you know what? Let's look real quick, because they might have added something about it. And let's see here. Making font bigger in Goland. Yeah, so it says go in and change it in here, which it's kind of gnarly. But maybe we'll do that anyway. Then a file, go to settings, and then here, use a toolbar, scope, system settings. Is it in this? No, editor. General. Oh, there's font. 12. Let's make it 16. A little better. Maybe 20. I mean, kind of got space actually, so we can probably go bigger than that even. Let's do 22. Hello? How did it not get bigger? Okay, I'm gonna try that one more time. Settings. Fonts. And this is 22. Line spacing and much font. Sure. Show only mouse font. Current editor value deja vu sans mono 12. Oh, color scheme font is specific. Crazy. There we go. I think probably that'd be just 20 now. There we go. Does it change it for everything? Yeah, sweet. Oh yeah, much easier to see. All right, so then let's go with this. And we'll say, let's look at, we're gonna look at the different types of formats. So format, print, line, and we're just gonna spit the thing out, right? So boiling F, right? We'll do dot to string. Did not do that. Oh, I thought I had. Oh, no, that should work. Grab root to header. Okay, we're gonna skip that one. So format dot print, and then print F. Do format, and then let's go with -v /n. And we'll go with boiling Fahrenheit. Okay. Then we're going to do one with format. We're going to do the string by itself. I don't actually know if it'll do this weird or whatnot, but we'll see. So print F again, and then string. Oops, new line. Boiling. And if we run that, you'll notice something. Oh, so the first one, %v, changes the value, which is 212. 212 degrees is boiling in Fahrenheit, right? You put your stove on 212 degrees, or well, more than 212 degrees. Eventually, the water in the pot boils, right? So, but thanks massively for the raid, by the way, CM Griffin. That's super badass. I need to figure out how to do that trick. I know how to do a raid in World of Warcraft. I do not know how to do a raid in Twitch. Noob me. So yeah, 212 degrees. Prints out with %v, but notice in %s, it says main.Fahrenheit equals 212. So it's printing out basically what the type, or the object type is and what it's equal to. So the key and the value in a sense. The problem, of course, that you don't see just the value 212 is because it's not doing a conversion to string, and %s is a formatter for a string type, right? So let's see if we do just this and then format dot, we do print line and just say boiling Fahrenheit. Let's see what that is, and then let's do format print F again. Let's say, let's do G /n for new line, and pass in the boiling there. And run that sucker. There you go. So notice this is automatically turning it into a string, but I do just a print line, and then this one is also turning it into a string and printing it out accordingly. So again, depending on which formatter or action verb is used, they call these verbs in Go. So I'm a little confused why they chose verb specifically, because it's a type formatter. That's what it is. But yeah, so anyway, it'll format your output based on various actions. I guess that's the point, because it's a verb. Verb is an action, right? So based on various actions, and then put it into the string, parse it out, etc. So, okay, that's all hunky dory. Let's talk about packages and files a bit. This, especially when first getting into Go, trying to think of a nice way to put this. There might not be a nice way to put this. Packages and files and dependencies in Go are kind of a pain in the neck. I'm presenting it as seamlessly as I think I can be in these sessions, but it's been a royal pain for people, especially coming from other languages. Like in C# you have NuGet. NuGet is pretty, how should I put it? NuGet's pretty easy to use. I mean, there's a few commands. The packages are pretty seamless. Once you start following some simple practices, just a few with NuGet, you basically don't run into dependency nightmares with things anymore, mostly. Same thing with Node.js. You have NPM. You also have Yarn. With Java, you have, I don't know, what is there, like 50 different solutions for dependencies? Pretty wild. Maven or whatever. So every language has some type of way to manage and keep up with dependencies. Some are more robust and some are not. Go's package management system is kind of robust, but kind of entirely not. So let's talk about that. As we talked about with our workspace, you'll notice, actually, let's see if I can look at that real quick. Pull up, and, why not pull it up? Just pull up in the terminal. And here, we have, figure that out. Let's echo the Go path that we have. Currently it's nothing, so it's the default, which would be user path that's squiggly, right? And then in here, there should be a Go. There is. And then in here, there's 3 directories: bin, package, and source. I go into source, and again, if you watch the first session, you're like, yeah, I already heard this, Adrian, blah, blah, blah. Sorry, just repeating, eventually we'll all have this super memorized. And in here is these various paths where projects are. So if I go to github.com, you see stuff that I have out there. There's my Adrian account. There's Derek Parker, Calendar, Rog Pepe, etc. Then if I go into my account here, you'll see that I have like the Hello World program, which I never put this one out on GitHub, but it's just a good example. I'm gonna actually delete that, go back, and then what Goland actually did for me is put awesome project out here. I don't know how I feel about that. That's kind of funny. I mean, not that it's Goland's fault. I let it put it out there. But what this actually, that actually needs to be in my path. So let's move awesome project to what is it? Let's see here. GitHub. GitHub.com. Adrian. Awesome project. We can do that. Okay, so then there, go ahead and GitHub, Adrian, and there's awesome projects, right? So that probably just nuked the pathing for that, yeah, so it doesn't know where it went. Let's open and move into the correct directory. Go, source, GitHub, Adrian, awesome project. So the reason I brought this up, though, is you'll notice that within source, you'll see a URI, generally speaking, where a remote repository of a dependency is. So these are actually paths that can be mapped out to projects on the web. Let's take a look at that. Yes, use this window. And let's open this up. And then let's go here. And actually, do this. So if you're in Windows, you type what, Explorer dot or Explorer, something like that, and it opens up the file manager. It's in the Go programming language, I think. Oh, good mention. So a lot of the material that I'm going over in this session, they're not booked at all. Not even looking at the book. But this one, get this book. This book is superb. It was one of the first ones on Go by Donovan and Kernighan. Good writers. But this book covers a ton of the central core Go language and libraries. It talks a lot about what it's for, the history of it, all that kind of jazz. It is the book to get. And also, if you join me for these sessions every Saturday at 10 a.m. for the next couple of weeks, or probably more than the next couple of weeks, probably the next 5-6 weeks, I'm going to be going through that book and through a bunch of additional Go material. So it should be fun. We'll have a good time. It's normal for what's Des. I like trying to pronounce that. I feel like I'm back in Poland or something. Sure thing. Yeah. So yeah, highly recommended book. I am about to start checking out some additional Go books that jump into some of the other stuff. Like I got Go in Action coming because I want to check it out. A couple other Go books. I know the authors, so I got to check them out. I got to see what they wrote. And some of them dive into very specific things like MUX and services for web services types of things. What I'm doing is just basic core, get started developing with Go, covering the types. What we're going to be doing is functions, concurrency, Go routines, all that good jazz eventually. So we're going to be covering a lot of bases, but won't be diving too far off into the weeds on other stuff until much later. So yeah, great book to get. You can follow along in it as we go through it in these sessions. And then, like I've said previously, lots of other jazz too. So we will get off a little into the weeds away from the book, but we're always going to be going back to the book to have that as the core material. Let's see, what was I doing? My brain got sidetracked. That happens a lot. Right, so we just went through the formatters there, and then Nautilus open the current directory, and then continuing running the thread. There we go. So you'll notice Go source. And then GitHub, then Adric. So if you look at these other ones, though, we can go out and we can actually look at these projects like calendars, Go, random data, and you can find it based on that. So let's go out to GitHub and just take a look at that real quick. So I can just type in the dependency path, go to github.com, calendar, there it is, it's already saved, because that's the dependency we pulled in last session to use the random data generator code capabilities of Go-random data. So if you go to that, though, you go to the GitHub page. It's really awesome that Go was written within the context of like modern development and its premise that so much is done in a remote Git repository. Specifically in this case on GitHub. You will also see things, and I think I even have a few. If you go back to source, you'll see golang.org. So that's where other stuff is done. I don't know what X is, but I think some of the main library, etc., is done on golang.org. If we go out to golang.org, it's this site. So if there's functionality that we're using from this site, it'll get pulled in as a dependency in the source path, as you just saw. Now, there's a way to do this with Go Git, and Go Git is part of the toolchain. Let's actually do a little search, pull that up, and let's see here. So here's the commands. Just type Git. There it is. Download and install packages and dependencies. Okay. Install will compile and install packages and dependencies. So let's say there's, let's say you want to get Yugo. And this, it might seem like we're getting off in the weeds here, but bear with me. These things they'll map in your brain about how they're being used. But it seems kind of weird at first. You're like, why is Go doing all these, why is it attaching to all these weird places out on the web and stuff like that? But it will make sense, I promise. So let's say Go, Yugo, GitHub. Not huge. Yugo. GitHub, SPF 13, Yugo. Also, when you're getting into Go, certain people also that you gotta follow. One is Steve Francia, SPF 13. There's Francesco, who does a lot of Go stuff. And I'll put a link to these people in the description on this particular stream, and when I write up the blog entry on composite code, compositecode.blog, I'll post it there, and I'll also reference some of these people because they're definitely worth following. Steve Francia does a ton of work on Go. Also, clearly eats tacos like you do. But let's take a look at Yugo. Yugo is a static site generator, very commonly used, and it has a CLI app in it, right? So if you scroll down, it says how to install, blah, blah, blah. And there is, of course, like the Go install option. So what Go install does, we go back to our directories, we go back to our Go path, the bin. If you do Go install, it will put things in here. So like I've installed Dep. Okay, Dep is the dependency manager, which does dependency management above and beyond just merely using Go Get. If you say Go Get, it'll pull down other things, and that's how you get things in packages and source. So now let's talk about our dependency of actually getting a package, right? So over here in Adrian and Awesome project, let's say we want to use that Go random generator again, right? GitHub.com, calendar. Back here, pounder, right? P-A-L, yeah, P-A-L. Okay. Fancy suit he's got there. So this we pulled down last time, and we just used the go get pound random data, right? So if you go out to the terminal in our project, cd awesome project, and let's look where are we at with git status. Let's add that stuff, all those changes, and that just shows the formatting. We did some funcs for Fahrenheit to Celsius, etc. Just to show that off. Put those bases again. I'm going to close Goland for now. We're going to do this via the command line. So git commit added temperature code samples and formatting. We go push, and this is actually in the branch of temp. What is it? Temp hard. Git status. Yeah, git add, git commit -m. Let's see. Added temperature code samples and formatting. And then we're going to do git push origin temp app, and that will go into that branch in the remote repository and be available as an example. And then it also tells how to do pull requests, even though I want it to be completely different. I want it to be just the temperature. Usually you're working on a singular project, and you'll want to create a pull request off of a branch like this to merge back into master. Don't want to merge into master, just going to have this as an example, so I don't need to do that. But in Git, it shows you how to begin that remote pull process. we'll do one of those later. Don't worry, I'll cover those bases too. But anyway, I am, however, going to git check to master, clear list, yep, and then do git branch. Let's call this, what should we call this? We're going to do looking at packages. Just going to call it packages. We're looking at packages and dependencies. So git check out of packages. There we go. Okay. Now I am going to go into code. Yes, we're going to start using a different IDE again and look at things from that point of view. So this is from, what is this? Go project 2, my 4. This is not even needed. So I'm going to actually delete this for now. I think I just left that in there from what I started earlier, but not needed. We don't actually need the text file either, so delete that again. And here, see, since I went back to master before I created this branch, it has the code from what we did in master. But also, don't want that, just want an empty file thing. There we go. And code is telling us, hey, this stuff isn't needed, imported and not used. So in Go, you have to take that, you have to take those things out. You can't have this in there. So I have no imports right now. Don't need any imports, everything's hunky. There we go. Main, func main, and of course it says, you're not doing anything, blah, blah, blah. That's what it's doing. How'd that go on? I mean, Visual Studio Code. Alright, so we have our gitignore, we have our main.go, and we have our vendor of nothingness. I'm going to actually delete that too so we can see all of the changes as we go through this. Now I'm going to open up the terminal in Visual Studio Code. Alright, and we want to go get github.com/Palander. What it is? Palander. Basically this path, right? And you can go here and you can get it from this almost always. You can almost just assume that if you don't see go get in the installation directions in the readme.md, which should be there, but sometimes they're not, you can still just run this and see if it works. And it should. So we're going to do go get Palander. Paste it in clean. There we go. So I'm going to pull that. So now that should put that in a place where it would be usable. And the Go toolchain puts that in that path directory back in the background that we've been looking through. Okay, you don't really have to worry about where it puts it. It does it based on GoPath. And in the future, it's going to do it based on other criteria, which we won't talk about just yet. But it's handling it for you. So don't worry about where the dependency is just yet. We're going to talk about where the problems come in just a second and how we fix them with Go Dep. All right, so we got that. And then I'm just going to paste in the big old example again, like we did previously. I'm going to take the func and all the random data examples. I don't remember them being that many of them. But anyway, they're there. And note also, they have the imports there for us. We're just going to copy it. And we are going to put it in here, like so. Boom. And scroll back up. And I'm going to save the file. And you'll notice also, code will put in the imports for you, just like Goland. And it gives the data, the name for random data is, I'm saying that all wrong. The function calls against random data, the dependency library that we just pulled in, you'll see here is put in the import. So it knows to look in that URI location, but you need to do go get first to make sure that you have it and that it's located correctly. But then locally, it's going to look in what is effectively source/github.com/Palander/go.randomdata. So if we go look in our folder here, and we go look in Palander, it needs to be here in this location. And sure enough, there's all the Go code for this random data generator, right? So now that it's there, this should run with zero problems. So if I say go run main.go, and remember, when I type go run, it's just going to run that one file. It's going to do like mock build and run that file. It's not doing anything else. So if we had other files, this would be a problem, right? But we don't. We just have the one. So we can do go run mag.go and runs it. You can pass parameters into it also, just like you're executing it as an executable via the command line. And you can also still do go build. It's going to give you the executable, right? Right there, awesome project, and I can run it and get the same results. There's all the random data. Okay, cool. So we have that. That's to get status again. And want to update with the, oh yeah, so I deleted those files. Now, what would happen if I committed this somewhere and then you needed to pull it down? You wouldn't have the dependency. You wouldn't have it in your source directory on your computer. And that would be a bummer. So how would you get it again? You'd have to know to run go get. What has traditionally been done with Go applications, people have created a make file which would go through and run all of these steps. But using a dependency manager like Go Dep is much easier. The way we do that is, let's get this in here first. Clean up first. Commit dependencies. Oops. C's. There we go. Clear. What we run is just like on Git, we'll do dep init. So when you start a Git repo, you type git init. When you start a Go project and you want to designate the dependencies in an effective way and use Go Dep, you type dep init. So there we go. And then say dep ensure. Dep ensure actually pulls the dependency and puts it in the vendor directory. So now we have it here too. So locally we have go get has gone out and stuck it in the source tree, so we can use it locally that way. But so it's packaged and known in this project, it's put in a vendor directory. Now you can technically distribute the vendor directory. The way Go works, you can do that. But I like to generally put it in an ignore file and not include it. So then you always build things pertinent to your system, and there's no assumption that binaries are being distributed with the project. So, and that might be Node kind of made me take up that habit, because Node's very specific on some of the things. It will use C or a C compiler like GCC to build pertinent to a system. But if you pull a Node project down on, say, Windows and it doesn't have a C compiler and you have some of those dependencies, it won't build, or it needs to build it specifically with like the Visual Studio C++ redistributable C++ compiler package thing. So I always like to have dependencies built to the machine that it's going to run on. And in the case of development, that is, I believe Go get, yeah, once you pass some like the dependency switch or whatever, it's always going to pull from master, unless they've done some weird magic per repo. But yeah, that is a good assumption. All right, so we have our one dependency. Let's look around for a minute. Whoops. There we go. This is all saved. Let's see where we're at here. So in this, Go Dep also is what adds the lock file, which you'll notice designates dep, and then it designates the dependency right here for the project, right? It also lines it up to the version, so you don't get version conflicts. And here, this file, the TOML file, is basically describing all that constraint too, about where the dependencies are, where the local dependency is, etc. It's very important stuff. Let's see here. Now, let's talk about another dependency thing. Let's say we go in and create a new folder. We'll call it, let's see here, food, for lack of a better thing. And then in that, we're going to create a, all right, code, where'd you just put a new file? Oh, there we go. So we're going to create a chicken.go. Okay. Now, in here, we can say package main, right? That makes sense. This is the part where things sort of make sense, sort of don't make sense. Actually, per the book, let's drop this one. What I want to do is I'm going to actually continue down, sort of down the path of like what we were doing with the temperature stuff, but we're just going to stay in this code. So I could say package main, and then this file, even though it's under food and chicken, would be part of the overall binary whenever I do a go build of what is being called and derived from main. But let's say, I lost focus on the image. There we go. Let's say instead of package main, I'm going to do temp converter, right? So here I'm going to put some of that stuff that I had. Yeah, actually, we'll commit this. Git status, git add, boom, git commit, samples, git push origin, git push origin, packages. We're going to go back to git, finish up, there we go, git branch. We're going to check back out temp app again, okay? Now in here we had all of our stuff, blah, blah, blah. But let's say we want to take this. Let's not take the constants, let's just take, maybe we will take that. We're gonna create a new file. And we're gonna call it temp convert.go. Well, let's call it something different so we don't conflate it. Temperature conversion.go. And then in here we're going to say package temp convert. Okay. And then in here we're actually going to take you're in the other branch. Oops. There we go. So we're going to take, let's say, take the types, and we'll take the constants, and we'll take the functions, boop, just like that. Now notice, we save it, stuff, yeah, see, stuff starts to flake out. We're going to put them in here and save that. Alright. That's all good. Then, let's see what it says there. It can't load package. Package, so this is important per what we're talking about with dependencies and everything. Let's see, is there a way to pull from another branch? I think there is with Go Get, but I don't remember the syntax off the top of my head. There's some switches or something where you can pull a specific one. Have somebody told you that there's not? No, there's, well, that's a good question. So you can definitely do a git pull of the dependency like that and put it in the source directory yourself. You can pull whatever you want, and then it's there. So it's just like you did a go get. But go get does make assumptions about it just pulling the master, because it's not trying to be a specific version manager, and it's not really trying to be a package. It's not trying to be a dependency manager for you, right? So that's why it's not trying to be specific about that. But if you go and you do a git pull, origin whatever, and put a tag on it, put a version on it, put a whatever with git, then you can pull it, put it in that source directory, and it'll be github.com/source/whatever, and then that whatever dependency is then available from that directory, right? So you can do it that way. And then if you use that dependency in your program and you go run dep ensure, which we'll see in a minute, it'll pull that dependency and put it in the vendor directory, whatever version it is that you've pulled. So whatever specific thing you're using in your application, you want to use Go Dep to pull that dependency, because Go Dep, i.e. dependency, Go dependency, is doing dependency management for you in a legitimate way versus Go Get trying to do just like a superficial grab of some code. So it's kind of a little weird, especially versus other languages. I've been a little frustrated with it, and I don't really know how I feel about it. It's just something that I've accepted. I'm like, okay, this is how Go works, and I use it that way. My main focus is what I get as a result, right? I figure out however I need to use the tooling and make sure I get the result. Let's see here. Where is that again? Okay, so we pulled this stuff into package temp convert, right? And then over yonder, where we're using it, yeah. So it says it can't find that because what it's actively, what code is doing with its plugin right now, it's actively going out and saying, okay, I don't see github.com/adrian/awesome project/temp convert for temperature conversion available out there, publicly available, right? Go tooling doesn't know that it's there yet. So if I save it though, and let's do a git status, just see what our changes are, that one thing, and then we added the temperature conversion file. Let's go back into main. Let's see what this says. Did it automatically auto find it for us? Convert. And then we should do, oops, we should actually add the dependencies for this. Did I have any dependencies? Oh, I guess I don't have any dependencies because it's just all, this is all native Go code, all core native capability. Yes, I think we're all set to do this. Yeah, now, so I can go into main, and let's see what code will do for us if I try to come in here. So this function is actually not going to work, right? Like if I say go build, we're just going to get this, right? Yeah. The most similar command is bundle. It doesn't even know, oh, go build, not go bundle, go build. So there you go. Can't load the package, right? It doesn't know where this temperature conversion thing is. I haven't put the temperature conversion thing where it needs to be, but I've declared the package. So now if in here I put temp convert dot, okay, save that. Let's see what this says. It says can't load package still. Okay, let's see if I can add an import though. Oops. Oh, we needed format. Whoops. There's multiple ways to do imports, right? You can do one import where it's import parentheses the import. Then you can do format, comma, temp convert, but it is, you have to put in the path from your source, right? So it's github.com, and I'm making this self-referencing. So it can be dangerous. Self-referencing references are, as we know, problematic sometimes. So github.com adrian slash what's our project called again? Awesome project. How can I forget the awesome project? Here we go. So then temp convert. Oh, I noticed some differences. So now it looks like it's finding this. Oh, I need a comma here. Yeah, so it's just each thing, like so. Yeah. Stop flipping out. Clear. Let's see what we got. Okay, so it still says that, right? Awesome project. Oh, because it's not that. There we go. Let's see what we get then. So still can't find it. So how do we have to do this? And that is the question. What is our repo that we have to get this? What I probably need to do is actually put this in a path. Is that what I need to do? No. So make sure this is just making sure one more time. Temp. So temp convert. Is that what I actually wrote there? Awesome project. Temp convert. There we go. So you can't load package. Awesome project. Template. Okay. So it says can't load package. Why is it that it says it can't load package? Let's actually try to go get github.com/Adrian/awesome project. Found packages main and temp convert. Note it found both of those things that we have made, right? Because we've got a package main and we've got a package temp convert, right? Starting to make sense now? All right, so let's see where we get now with the go build. Found packages main and temp convert in blah 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 blah. Can't load package, but it found them. Okay. It's really confusing us. Let's status git add git commit. Oops. Now this is where things get a little trippy. Yeah, exactly. Question mark, right? Origin. Oh, what do we have? Temp hard. Yeah, that's right. Now, let's do git checkout. We're going to lose master here. And this goes back to, yeah, this actually goes back to your exact question, PJ, about go get. So we're going to go back to master, and we're going to get merged with temp app. Right? So all that stuff is now merged into master. Master loses some of this and that. We're going to do git push origin master. Okay. And we're going to do go get github.com/Adrian/awesome project. No. Yep. So just for example, real quick, if we did this main, we went back over here, and we got rid of this, we got rid of this, you can kind of see what I'm trying to do, right? So the questions go away. Oh. See, ta-da, builds, right? Let's not do that. We're trying to build a dependency again. So that's there. What did I just do? I put a bunch of stuff back that I didn't want. And over here, this is going to be convert. Like so. Yeah, you're on the right path. So actually, let's do that as the next step. So let's take and add a folder, temperature, and let's put the temperature conversion in it. Right. Move that, so it's all in there. Things have stopped going up there, but we still have this, right? There we go. Such. Non-canonical import path. Let's actually do this. Is that gonna work? Should be awesome. Perfect. Wait, what did I misspell? I misspelled something. Or do I need to do that? Import cycle methodology. Oh, I just added too many bits there. For sure. Ah, there we go. Okay. Oh, and the constant. Where's the constant is in the middle? So there you'll see. Now, temp convert that boiling Celsius should be available. Yeah, there we go. And also, this is kind of cool. Code says that %s has our boiling F with wrong type, blah, 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 temperature Fahrenheit. Yes, it does. So here, let's do go build again, and what do we get? Boom! It builds, right? So, you'll notice from all those steps that I just went through that it's, I tried to follow what traditionally I would think is the standard way to just declare another package, right? But you can't really declare another package in the root like that. You have to put it in a folder. And that is the way things are organized in Go. Again, convention-based, right? So here's our package temp convert, or temp conv, which kind of follows Go naming, because they like to shorten stuff, which I've always been taught. Don't shorten stuff, actually spell it out. Use various casing, etc. But that's how they do it in Go. Yeah, exactly. That worked. I would, even when I'm being sneaky and just going through all the like broken examples of something, I always feel that way when I get something to work. So yeah, here's us breaking this out. This is a great example of refactoring too. So we've effectively refactored the constants for Celsius at absolute zero, freezing, and boiling, and we've put in the two funcs for Celsius to Fahrenheit, Fahrenheit to Celsius in here, and we put it in a package called temp convert, or conv, whatever. And then in main, we have referenced it accordingly and assigned it to this, which I just could do this, T, and then say T, and then T. And that would be kind of Go-like too, because I've just shortened it to the nth degree, and you just have to look at the reference to see what it is. Kind of not readable, in my opinion, because if you shorten things to too short of a degree, and then expect people just to remember what T means, or X, or P, or whatever, it doesn't always happen, period. End of story. Our brains aren't going to remember that kind of stuff. But in this case, the convention is to shorten it. We have it assigned to that package dependency, which is in a folder, has to be in a folder that then can be referenced. And because we have it in our source path, Go, if you do go get, can pull it from a URI point and put it in the source path, which we already have it in the source path, right? Which then references it for us as a package dependency. It's doing it the same way as when we looked at the random data, right? So when we pulled in the random data example with go get github.com/go random data, it pulls it down to source and it looks at it not really as a specific dependency, but just as local code in a package, right? Because each of those things is in a package file. So that's how we would write our own packages and distribute them out unto the world via GitHub, okay? It can be confusing, but as we look over it, as we study it, as we do more examples, this is going to become second nature, and it actually becomes quite easy because there's very few steps, and fewer steps to remember makes it easier to build this stuff. Also, just to speak from historical context, these types of dependencies in C and C++ were crazy difficult to pull down and manage, okay? We're talking about just all sorts of frustrations. There wasn't a tool to do it traditionally. You had to have the header files, you had to have the dependencies files, and they would be brought into somewhere, and then you'd have to build them and then connect to them in various ways with C and C++. And those were the languages that were traditionally used to get a native binary to execute. Go gives you that native binary when it builds, like C and C++. That's almost as fast as C and C++ per system, but it gives you all of this dependency tooling stuff that helps you manage these things. So even though it might seem complicated, it's dramatically simpler than other tooling frameworks that would actually give you a native binary. So it seems complex, but it's actually a pretty big step forward in simplifying a lot of that. So is that good habit to? Oh, let me look at chat real quick. What do we got here? You also don't need to use a variable on the package import. Right, you don't need to use a package import because then it would just use the name of the package, right? In that case, the IDE actually put that there for me originally. So I'm glad you mentioned that. That's a super important thing to note. It's good to use if you want to give it a specific name or you want to shorten it like I did just to T. But also you can just import it and just use the name that it comes with, right? Like with Go random data, it shortened it down to random data, right? And then we do random data dot whatever function. But you know, maybe you just want it to be rand or something, or that might be a reserved word, but you just want it to be random, right? You could put that in there, and then you wouldn't have to have super long dependencies names. And also, as we push things up into GitHub and make it available, sometimes we end up with long names to differentiate from other functions, and that's where that kind of stuff comes in handy. It's the same as other package. Oh yeah, that's the other thing. If there is a conflict, you can give it a name. Good call on bringing those points up. Very, very good points. And we'll see more of that too as we work through things because we'll run into little conflicts and then we'll just fix them. I'll show you how to go through all of that. So what is your name again? Code phobia. Code phobia. Why do you have a phobia of code? Code phobia. That sounds recursive. I have no phobia of code, but I have phobia of not having phobia. I think that's my big problem. So let's see here. We have that. It's a cool example. Let's commit that. Ah, ironic. Of course, I should have assumed that. I'm being too literal again. I have a literalishness problem. Maybe I should have a phobia of literalness. Git status, git add, git commit. Cool package reference dependency sample. Boom. Also, just to point out in Git, if we go back to what we just committed, just want to talk about branches real quick because we get weird things depending on what we do. I want to make sure I cover these bases. So here's our Learning Go episode 2. Here's our things to merge. Except like I was saying earlier, I don't want to merge them because you know, they're different examples. Even though I did just merge on the master, which completely dorked up the first example, right, which was the editing or manipulating the text file thing here, right? Which is weird. Didn't I just commit that? I thought I just committed it. Should have overwrote it. Oh yeah. So it says, oh yeah, failed to push refs because it hasn't. Oh, because I haven't synced it up. But that's okay. I actually this example is a little less important than the other one. The other one is pretty cool. This one. So this is on master branch, but then on GitHub, if you just click, you can of course pull down these with fetch. We'll talk about that later. Don't need to dive into that now, but I just want you to see that each of these branches has the different examples, right? So here's our random data example, and then here's our temp app stuff in main. And I have to go to root here. And see, we're still on temp app branch. You can see, oh yeah, so the paths aren't in there. So let's actually put that on in the right place, right? So go over here.
Git check out path. There it goes. Temp app. We did this. We got the functions. Oh no, I just nuked them. Genius. Anyway, I'll sync that up. I'll put this example out there. We don't need to go through that right now. So, next things. Got some good stuff. We've been at it for like 2 hours though, so it might be a good time, especially as we let packages sink into our brain. Kind of. See ya.